Oh, I'm Merak Ramlu, product manager here at Kalana, and I wanted to talk about a new capability that we have provided on Kalana dataset, and that is using embedding space visualizations. So in this example, I'm using an object detection COCO 24 dataset, and this is a person detection problem. We have a number of model results uploaded onto the platform, and we have a number of images that these model results are trying to detect people from. So what I'm going to do, I'm going to use the leaderboard that highlights the most performing models. I'm going to use the leaderboard to compare the top three models in my quality standard. Here I can see the performance of these. But today I'm interested in better understanding um, the model performance and the difficult data points and how I can find similar data points like those difficult data points. So what I'm going to do here, I have an embedding space visualization. I'm going to turn that on, and we have a UMAP, TSNE, and PCA space reduction functionalities available, and a number of common embedding and space visualization capabilities, yeah, like being able to color the points by the metadata that you have provided in your data set. So again, it is on its own is a great tool that helps you understand the clusters. You can switch between different space reduction functionality and decide which one is the one that is doing the best job. And hovering over the data points, you can see a quick preview of that data point and image. Selecting a point will get you to the details view of that point, and you can see all the information that is provided here in terms of the ground truth and the model results. So what I want to do, I'm going to select UMAP. I see good separation here. I'm going to remove the color by. And what I want to do, I have three models here, and I want to apply a filter on my difficulty score. So difficulty score is a score that is calculated by Colonna, and it is a representative of how difficult your models have found specific data points. Let's say I want to look between zero point 0.8 and 1, which is the top 80% of top 20% of difficult data points. And very quickly, I can see the clustering of difficult data points. And these are models, these are data points that my models are finding difficult to classify or find people in. I'm going to focus on this cluster. So we have a number of them, but I want to focus on this cluster to better understand what's going on. So quickly hovering over these, I can see that there are boats available here. You have settings that allow you to play the opacity of different points, and that is like the complete data set versus the filtered subset. You also have the traditional lasso tool where I can lasso that part and better understand what those images are. So lassoing these images will filter your gallery on the left-hand side. So you can really see what's going on. You can see, hey, there's a lot of boats here that the models are having a tough time with. I'm going to remove that, and then it seems like there's other data points in that cluster. I'm wondering what these are. And then hovering over them, we could see that these are water sports. So the models are doing a better job detecting um, basically people on surfing and people doing water sports. So it seems like the model is having a tough time with boats and water, but not as difficult time of people water sporting. So this informs me the areas of the model that I can focus on improving. Now, most of this data set is labeled, but if it wasn't, what I would be able to do is that use my labeled subset of data points to identify clusters that are difficult to classify, and then use my lasso tool to select group of data points that I think are my models find difficult to export and use for training. Maybe use this method to identify data points that need to be labeled to reduce the labeling cost. So here you can select these pages and um, export the selection for additional post-processing, labeling, and doing other things with that data. So I can download this as a CSV with the extractor properties or without them, and then send that to my labeling company. So this was a good example of very quickly how we can use the embedding space visualization to better understand our data. A couple of things I want to mention on the embedding space is that you can upload your own embedding space or embedding extractions onto the platform. We can use those, or we have an automated embedding extraction pipeline here that is basically a toggle. If you enable, you have access to all of these features. Thank you very much for watching.